Hello everyone, good morning, welcome all of you. Alright guys, very welcome, very good morning once again. So basically we are having this session, another practice booster session on the photochemical reactions. So as you can see, good morning, very well. Alright guys, so once again good morning to everyone, and yes, so we are doing photochemical reactions this time. So basically, most of the topics have been completed in on the Unacademy in special classes. And right now, as I have already told you, we are having this very important last minute question practice session. जो कि we are having 3 sessions which are in which we are doing a lot of good question practice. So if you haven't already attended, please do. So 21st November and 22nd November sessions are already done. You are going to get the recordings. You can watch whenever you get time. 23rd November, that is today itself, 8:30 p.m. we are going to have the third session, the third last minute practice question session, right? And further on 25th of November, okay, so pay attention guys, 25th of November 9 a.m. we are going to have the smart approach to maximize marks, okay? And I will send you the link in my Telegram group as well, which you know goes by the name CSIR NET 2020. Okay, so smart approach to maximize marks. Alright, we are going to discuss about some very important last minute strategies and how to attempt your paper. Finally, on 27th of November, we will do memory based question paper analysis, which I know is very important for all of you guys. Okay, so 27th of November, 8:30 p.m. we are going to do memory based question paper analysis, and 29th of November, that is gate strategy for 2021 exam. Okay, so 8:30 p.m. we are going to talk about gate strategy, because yes, our next course from 1st of December we are starting for the gate preparation. Okay, so as you can see, these are all free classes, these are all special classes, as you already know. Yes, all right. And along with that, we also have our free YouTube session just like this one. So today we had the photochemistry session. Organic reagents is left out before your exam. And along with that, we also have the DNF block element question practice, that also I'll tell you. So once again, let me quickly inform you about all the batches. Yes, and also tell me guys if the voice and the video is all clear to you. Yes, is the video clear to everyone? Alright, so yes, 1st of December, 1st of December exactly, we are going to start our practice booster for gate chemistry. Okay, so this is going to be a batch course, as you see. This is going to be a batch course, SD Chemistry sir, me and Nurul Huda sir. So we will be covering all the important topics for your gate examination so that you score maximum. This course will be from 1st December to 31st of January. That is, it is a 2-month course. Okay, and side by side along with that, you have another new course which is going to start very soon. As you can see, June 2021 batches are going to start very soon, like in December only we are going to start. In 1 or 2 days you will get the courses. So from 1st of December we are starting beginners course as well. Beginners course in which we start everything from the basic, everything from the very basic, okay, for your June 2021 preparation as well. So you are going to have 5 new courses in which you see 1 and 2, these are the new courses already that have launched. ये हमारा practice lesson है जो चल ही रहा है right now for the JRF. Okay, and more 3 more new courses and the courses are planned from December till March. Okay, after March or April, we are going to start our revision. So we are going to study our theory till December, from December to March or mid of April, and then we are going to start revision. So the revision courses are going to launch later. Okay, good morning. Yes. And guys, this is the perfect time if you want to subscribe, and I want you to notice this one thing. CSIR subscription is time based, it is not a course based. So you're not paying for one course, you are paying for the whole CSIR subscription, in which you are getting all the educators. So you're getting all educators including aptitude. Along with that, you are getting all courses. All courses, whether it is the upcoming course or it is the completed course. All right, so for the completed there will be recordings, and for the upcomings you will have live sessions. Okay, so it is that easy. Along with that, you have doubt clearing session and quizzes as well. So constant practice. And guys, I want to tell you that if you are thinking about joining for 1 month, and if you like the content, and then you will join for 6 months, that is going to cost you a lot. As you can see, it costs you around 11,000, and that 11,000 is going to give you directly a 12-month subscription. Okay, so choose wisely, and don't forget to use the code, that is JagritiS. You have to use the referral code right over here and proceed to pay. Further, when you use the code, we get 10% off like this, and then also apply the credit points. This is how you subscribe, and the amount reduces to 9356, or even less, right? So also ask me about this if you are having any trouble on the Telegram group as well. Alright, yes, everything is clear. Now we are going to proceed to our important question discussion. So guys, photochemistry, I have taken most recent questions. Okay, the major product formed in the following reaction is. Now this question was asked in June 2019. Yes, good morning all of you once again. Yes, so now what do we see? What do we see in this question? What is this reaction, guys? Can you tell me? NOCl and pyridine, and there is an alcoholic group. Yes. Does it look like the Barton reaction? What do you say? Yes, very well, all of you. So, yes, it looks like the Barton reaction, that is the Barton remote functionalization. So, first of all, in the presence of pyridine, the proton is being abstracted. And let me just write it like this. So, oxygen is going to attack over nitrosyl chloride like this. Chloride gets removed, and you have the nitrile ester now. This is called the nitrile ester. Only drawing this 5-member ring, because you only need to deal with this. Now what happens? Do we abstract the delta hydrogen? So alpha, beta, gamma and delta. Alpha, beta, gamma and delta. So this proton will be abstracted. Alright, when the photolysis happens, the photolysis of the nitrile ester bond opens up, and similarly the oxygen radical which is generated, as you can see, is going to abstract this delta hydrogen. So that gives you something like this. You get OH, and to the radical which generates the nitrosyl group is connected. Okay, very well. Now further, you also have to take care of this stuff, that you are having acid. What happens in the presence of acid? tautomerism happens and you get the oxime like this. So you are going to get the oxime like this in the tautomerism. Further in the presence of acid, you get this kind of hydronium ion formation, which you know is a good leaving group. So when it leaves, you're going to have the migration of a carbon-carbon bond, like in the Beckmann rearrangement. Okay, and then only you are able to get a 6-membered ring from a 5-membered ring. So first thing you see that there is a nitrogen inserted in these 6-membered ring, and the ring expansion happens. You must be able to understand this, that there is Beckmann rearrangement, isn't it? Yes, so 5-membered ring goes to 6-membered ring with a nitrogen inserted. It has to be the Beckmann rearrangement, right? Okay, very well. So you have a nitrogen, you have a double bond, and you have 2 carbons like this, and this double bond carbon has a positive charge. Okay, because one of the bonds have opened up. Now the water could attack this positive carbon, and you know what happens next. So that is going to give you a ketone. Okay, why ketoenol tautomerism, and your product has to be option number B. So yes, you see the nitrogen right over here inserted, and onto this carbon you are going to get the first step you're getting the enol, second step you're getting tautomerism, and then ketone. So the reaction was Barton nitrile ester rearrangement, or let's say remote functionalization. Second reaction was Beckmann rearrangement. Very well, guys, very nicely answered. Yes, Gayatri, hopefully they are going to give you the calculator, but till now what you can do is you can do some practice by yourself also. Yes, most probably you will get the calculator. Alright, so B is our correct answer in this very good question asked in June 2019. Next is an easy question which we have done. Let's revise. The major product formed in the following photochemical reactions are. Okay, what do you say? Alright, so according to you, what must be the correct answer of this question, everyone? Okay, so you are responding for option number A. Let's see. Acha, even if it is A, then what is the mechanism? What is the mechanism that we are going to follow in the presence of light? Is it the Norris type 1 or Norris type 2 reactions? Quickly. Alpha cleavage. Yes, everyone, I hope that you remember alpha cleavage gives you Norris type 1 reaction. Okay, Norris type 1 reaction like this. So it is the alpha carbon cleavage in this manner, and further, you know, there is a double bond in the ring. So further, these bonds, they can open apart like this. You get further 2 radicals, so they can join now to give you a cis alkene either over here. So you know, either you get a cis alkene so the product is going to be something like this. So I have just wrongly written this over here. It is going to be in this manner. Okay, you are getting a cis bond. Just be careful about the numbering. So 1, 2, 3 and 4. 1, 2, 3 and 4. On the 4th position you get the double bond, that is also cis. Okay. Now similarly, This radical can also form. This radical is forming by opening up this pipe, this bond. Let me just show it to you that you have a radical once again like this. Okay, and then further the trans bond, if it opens up, you are going to get this molecule, right? Okay, this is another process. So here you are getting a trans bond. So if you just finally want to check out the product, this is going to be the trans product, trans alkene forms, and 1, 2, 3 and 4. The position of the double bond always has to be fourth only. So our answer is option number 1. What is wrong with option 2? It looks like trans is okay, but the cis bond is on the alpha beta position. That is not going to happen. Similarly in 3 the same thing happens wrong. In option number 4 you have a cis and a both of these are cis. Both of these are cis, once again not happening. So you get both the possibilities, cis and trans. The position of the carbon must be C4 where the alkene is present, and it is Norris type 1 reaction because you don't have the gamma hydrogen. Yes, even if you have the gamma hydrogen, alpha, beta and gamma, you still have a hydrogen, but that does not help us in predicting the products this way. Okay, so yes, even if there is a gamma hydrogen, the answer would not be predicted. So we go by the Norris type 1 reaction. Yes, easy question. Let's do another. Major product formed in the following photochemical reaction is. And what is the type of reaction? Is it Norris type 1? Is it Norris type 2? Yes, so I have taken some question from your December 2019 paper also. We will discuss that very soon. Okay guys, very well. Yes, so we have tried out the mechanism and we see that if there is a gamma hydrogen in this manner, there is a gamma hydrogen, right? So what is Norris type 2 reaction? Norris type 2 reaction is first of all gamma hydrogen abstraction followed by the alpha beta carbon carbon bond cleavage. ठीक है? Very predictable it is. Okay, so you have a gamma hydrogen. This is the alpha carbon, mind you, because the carbonyl is right over here. Alpha, beta and gamma. Okay, so yes, what do we do next? We are going to do the photolysis of the carbonyl bond. Okay, so it is going to be forming a diradical in this manner, and the diradical abstracts a proton from the gamma hydrogen. So if this was our gamma hydrogen, it has a radical itself and a radical on a carbonyl carbon. So basically first is gamma hydrogen abstraction, second one is cleaving the bond. So let's say if you open up this bond, to make a double bond like this, okay, you will get another radical on this side. So what will you have ultimately? Ye dekho. So we are having something like this. There is a single bond, there is an enol now. There is an enol in this manner. There is a double bond over here since one of the bond has broken down. Now you understand where is the double bond. So from this connection to the ketone system, it is on the second position. So if we just simply want to write the 5-member ring, and let's say we got the connection over here. Okay, then on the second carbon we see a double bond, the second and the third. Yes, ये हो गया हमारा option number B. This is our correct answer, isn't it? Because on the second and the third carbon we get the double bond. So be careful about it. It's not like this, completely wrong, not like this as well. And ये तो बिल्कुल भी नहीं है, alpha beta unsaturated. So It is option number B. Yes, Norris type 2 reaction. Very well, very nicely answered. Moving on to next very important question. As you can see, ये देखो, ये वही रिएक्शन है जो 2019 जून में आया था. The photo enolization reaction and photo deprotection reaction. Alright, so basically you need to try out the mechanism of this one and tell me what is the major product. Okay, so what do you say? A and B, you have to find out. Alright. Okay guys, so no responses. Have we done this one before? Yes. Alright, so what do you say? Let's just quickly do this. The first one that you see is a nitro group, right? So the nitro group basically is going to be like this. You have a proton over here, 2 protons you have, और ये हो गया है ester group like this. ठीक है? Alright, very well. So what do you get guys in the nitro group? Nitro group has a double bond, no, over here. Yes, the nitro group has a double bond towards the oxygen. So we are not going to write the double bond, we write radicals like this. Just like the carbonyl is dissociating, no? And it is doing the delta hydrogen abstraction, same thing it is doing over here. So we can consider this as Norris type 2 reaction. Actually, just a similar to Norris type 2 reaction. So this is what you have got. You have got the N-hydroxylamine looks like, but there is an oxygen also. So here is a radical which is formed. So there is a radical which is formed. Can you shift the bonds a little bit? Yes, can we shift the bonds? After shifting the bonds, do we get something like this? Yes, tell me guys, are you all able to follow? Yes, everyone is able to follow, right? Okay, now what is the possibility? The possibility is the attack of the OH onto this adjacent carbon, which has the double bond, and further the bond could open away like this. Okay, so yes, I hope that this makes sense to all of you. Yes, very well, guys. So what we are having actually in this whole reaction is of the photo deprotection. You see that there is the carboxylic acid basically, or let's say what we have generated is EtCO2 minus. It can take away a proton from the medium. Okay, it can take away this extra proton which was abstracted, right? And yes, so this is our byproduct which you have got through this mechanism. So ultimately, what are you doing? First of all, you are breaking the nitrogen oxygen bond and generating two radicals in a similar manner as carbonyl. Then the hydrogen extraction looks like that it is your alpha, beta, gamma, and delta. Looks like it is the delta hydrogen only, very similar to Norris type 2 reaction. Yes, right over here, this step. Now the abstraction of the hydrogen is going to give you a shift in the electron density, as you can see over here. This shift in electron density now pushes the reaction in the formation of a 5-membered oxazolidinone ring like this, right? So oxazole ring that you have further breaks down when the O minus attacks on this double bond, and the nitrogen loses the oxygen nitrogen bond like this to give you the following product. So this is your major product, and further byproduct is the acid, or let's say the carboxylate salt. So you have nitrosyl and CHO, isn't it? You have nitrosyl and CHO, not the NO2 and not CH2H. This you can understand just by balancing the equation, that what you are getting, what you can get, because no atom is going to be lost. ठीक है? McLafferty. Norris type 2 and McLafferty are exactly the same thing. Okay, so McLafferty happens in the mass fragmentation, yes. Alright, and Norris type 2 we consider in the photochemical reaction, but ultimately it's the same thing, right? So we now basically remove everything and make space for the second one. ये तो हो गया था guys, first one done. You are getting this part A and D, not in B and C, wrong. Now we move onwards to the second one. What do you think is happening? Okay, like always, we are going to generate two radicals. Now these two radicals, so you have something like this. Finally, you have these kind of two radicals. Now, how are these two radicals going to react? We also have to see that. Okay, so I am just rotating this oxygen, just rotating this oxygen on the backs on the lower side. So you have bond movements like this. So the ethoxy is going to get removed. Right, the ethoxy is getting removed over here. You get the 6-member ring like this, a double bond and this methyl group. Okay, so what did we exactly do over here? We are getting back the same thing, no? तो इतना हम लोगों ने क्यों किया? Because here you have a trans double bond. You have a trans double bond over here, and we are doing the isomerization till now. Okay, to get the cis double bond. If we get the cis double bond, we have the possibility of cyclization, right? तो ये हो गया है cis double bond. Further, that there is oxygen attacking over this carbonyl so that the ethoxy group removes. एक तो ethoxy और hydrogen निकल जाएगा from the oxygen itself. So your byproduct is going to be ETOH. Now the second reaction is very easy to understand. This is very easy to understand. You are just kind of having the intramolecular transesterification, just that we need a cis double bond, nothing else. तो ये हो गया है हमारा आंसर ऑप्शन नंबर बी. सो दिस इज आवर करेक्ट आंसर. ये देखो, दिस इज रॉन्ग. ऑप्शन नंबर बी इन फोर्थ इज रॉन्ग because it is still giving you an acid. How are you getting the acid in the presence of light? We don't have any acid hydrolysis condition, so not happening. This is wrong. So answer is option number A. Okay, so I think that this makes sense to all of you. Yes or no? Shall we move onwards? Chalo, next easy question. Next question is very easy. The major product P is. Also tell me the name of this reaction along with telling the product, okay? Okay, so what do you say? Alright, yes, Hofmann, Luffler, Freytag reaction. Very good. What next? What is the major product? Yes, everyone, you are correct. It is the, it is the Hofmann, Luffler, Freytag reaction. But what is the product? Product is option number A. Very good. So, see, what we have to be careful in this reaction is that Hofmann-Luffler-Freytag reaction, it is a reaction for the N-halogenated amines. Yes, right. So we have protonated. First of all, see, this nitrogen has a lone pair. It's going to grab a proton from H2SO4, becomes a positive charge like this. Photolysis or thermolysis of this N-halogenated amine. Gives you a radical cation like this. Now this radical cation would further remove a delta hydrogen. So alpha, beta, gamma and delta. This carbon is delta carbon. So the bonds are going to move away like this. Nitrogen once again gets a positive charge and there is a radical over here. Alright, there is a radical, and who was free to attack over here? The Br radical, which has eliminated. Okay, so you have minus Br radical. This is free to react. So further you have very quickly, we are going to see we have this radical. See guys, whenever, even if you know the mechanism, try out the mechanism, you might get something different. Okay, so alright, this was normal mechanism that we had. Nitrogen still has a proton on it. Very good. In the option number 2, we are having a base, a strong base. What is the base going to do? The base is going to remove this extra proton on the amine, right? Otherwise we end up over here. If there is no base, we end up right over here. If there is a base, the extra proton is removed, nitrogen can once again cyclize. So only in the presence of a base, once again I am repeating. So this is what you have. Alright, ये हो गया है हमारा major product, option number A, from the Hofmann-Luffler-Freytag reaction. And the thing is, always pay attention to what are the reagents present. You don't only have the acid, you also have the base. बेसिक मीडियम में होता है साइक्लाइजेशन. Alright, to give the pyrrolidine derivative, answer is option number A. Very good. So let's do another very easy question. Okay, very simple question this is. Correct statement about the following reaction is that. Alright guys, so yes. Definitely it is easy. Okay. So in the presence of light, what happens? Dissociation of the diazo compound to give you a carbene. Like this. So yes, now you get something like this, and further when the methanol attacks, onto this carbon, you get something like this, and there is the proton that you have. Alright, bond is going to shift, so it is not going through Norris type 1 or type 2 because we have the breaking of diazonium going to happen first. So our answer is option number A. This is a question which is not involving the photochemical reaction. Alright, chalo move onwards and see another good question. Good morning guys. Major product formed in the following reaction is. Now this question was asked in December 2019. So guys, in the photochemical reaction also practice the vinyl cyclopropyl to cyclopentene rearrangement, the dipymethane rearrangement, lumiketone rearrangement, all of these. Yes, so looks like correct answer. Tell me then, what is the type of reaction that you have followed? Norris type 2, is it? Yes, very good. So if we are doing the Norris type 2, we first have to spot alpha, beta, gamma and delta. You have a methyl group like this. So the answer is option number 4, and you are getting the Norris type 2 reaction only. Option number 1 is highly strained. It is a highly strained molecule. Yes, so it is highly strained molecule, so it is not happening. Norris type 2 reaction में क्या होता है guys? It is either it is gamma hydrogen abstraction followed by the alpha beta cleavage. We could also have done the alpha beta cleavage like this, but there is no option which is given according to the alpha beta cleavage. Let's say if we did the alpha beta cleavage like this, so for example you have the bond opening up from here, so you are going to have this carbon intact, and along with that you have another alkene system which is also present, but these options are not given in the options. Not given in the option. So hence we are going to say कि चलो alpha beta cleavage नहीं है, Norris type 2 can happen. After Norris type 2 you can go for the cyclization like this. So 4 is the answer. Okay, just a second. Let us see once again. अल्फा बीटा गामा, हाँ सॉरी ये वाला मैंने डेल्टा हाइड्रोजन कर दिया. All right guys, so sorry. So let's see once again the same mechanism we are going to see this time, and we have to remove the gamma hydrogen. Yes. Yes, right? Otherwise we won't get the methyl group. Okay, so 1, 2, 3 and 4. Now it forms a 4-member ring. And it also has this methyl on the terminal carbon. Yes, otherwise we won't be able to get this methyl. Alright, so answer is option number 4. ठीक है? Yes, चलो. ये हो गया Norris type 2 gamma hydrogen abstraction followed by the cyclization. Alright, we have another good question guys. Irradiation of either cis or trans still beam at 313 nanometer. मतलब कि you may start with the cis still beam or you start with the trans still beam. Doesn't matter. Irradiation of both of these at 303 nanometer results in the formation always of 93% cis and only 7% trans olefin. So see guys, even if you are starting with 100% cis stilbene or if you are starting with 100% trans stilbene, still you are getting the same mixture at this frequency. So what do you think is the reason? Because, so what is the reason for this? Can you tell me? First one says trans stilbene is more stable than the cis stilbene. तो इस हिसाब से तो ट्रांस ज़्यादा होना चाहिए था, but it is not. The extinction coefficient of trans stilbene is greater than the cis stilbene at exciting wavelength. The transition state structure of cis and trans stilbenes are different. The triplet excited state of cis and trans stilbene are at different energy levels. So what is this question? Okay, what do you say? Why is this happening? Okay, so actually guys, it is about, see, the trans alkene, whatever alkene it is, when you have the trans alkene, it absorbs more readily. It absorbs the light more readily. It gives your radicals more readily, and then it does the rotation and forms the cis very quickly. So the extinction coefficient of trans stilbene is greater than the cis stilbene at exciting wavelength. What does that mean? कि जो cis stilbene है, it is going to, yes, so alright Sophia, I got it. So basically the thing is, the extinction coefficient, that is the absorption or absorptivity of the trans alkene, is much greater than the cis alkene, and hence it absorbs light much faster, or let's say much greater as compared to the cis. So if the cis is not absorbing, ये तो ultimately cis to trans isomerization है. Yes, it is a constant cis to trans isomerization of the alkene. But if your trans is faster in absorbing, that the arrow goes more towards cis, so you get a greater percentage of cis as compared to trans, क्योंकि cis तो बहुत ही slow reaction कर रहा है and trans बहुत फटाफट reaction कर रहा है, so you get a greater percentage of cis. That is what we see over here. So the extinction coefficient of trans stilbene is greater than the cis stilbene at exciting wavelength. Transition state structures are different. Okay, that is not much different, very similar. Triplet excited states of cis and trans stilbene are at different energy levels. So that is also correct. ठीक है, ये correct है क्योंकि ये logical है, different तो है ही, but is that giving you the answer of this question? No. Alright, answer is option number 2. चलो लेट्स मूव ऑनवर्ड टू अनदर गुड क्वेश्चन. ये मैंने गेट पेपर से लिया है. मेजर प्रोडक्ट फॉर्म्ड इन द फॉलोइंग रिएक्शन इज. सो यू हैव अ वेरी क्लेवर क्वेश्चन ओवर हियर. नहीं काजल, डोंट टेक दिस रिस्क इन दी एग्जाम. ओके, प्रैक्टिस तक रिस्क ठीक है, एग्जाम में रिस्क नहीं लेना है. बिकॉज द नंबर ऑफ क्वेश्चंस आर वेरी फ्यू, वेरी लिमिटेड क्वेश्चंस यू हैव. ऑलराइट, so what do you say? What is the major product? Be careful about the stereochemistry, because I think that you must first of all understand where is the less hindrance. What is this molecule guys? ये देखो दोनों हाइड्रोजन below the plane है. Okay, once again I'll tell you to be careful about this one thing. Let me just draw it. So the rings are like this, no? Yes, the rings are like this. अभी देखो there is a double bond right over here. ये इस तरीके से जा रहा है, isn't it? So which is the less hindered side? Which is the less hindered side? The above or the below? Tell me that quickly. Okay, this methyl guys, till now as long as you have the double bond, this methyl is going to be planar, isn't it? Because it is connected to a double bond, so it is in the same direction, it is planar. Now when the attack happens, the methyl could go above or below depending from where your molecule is getting attacked. Yes, tell me quickly. This is our 2+2 cycloaddition, but what is the stereochemistry? What is the regiochemistry as well? When you are having the 2+2 cycloaddition, you can consider the radical formation. Okay, and the more stable radical is going to persist till a longer time. So let me just tell you about the regio. Just drawing one ring, okay, not drawing the other one. So the regiochemistry is going to be like this. These are the two radicals that you get even after your combination, ठीक है? And finally they are going to combine to give the selectivity in such a manner that with the methyls you have two of these chlorines. Okay, so be very careful once again. Okay, so once you have understood the regio, you say A and D are wrong. What could be correct? Either it could be B or it could be C. But now you have to determine the stereochemistry. Yes, now you have to determine the stereochemistry. Bilkul. So guys, isn't that obvious? Just now I have told you, isn't that obvious कि अगर ये structure इस तरीके से, if it is a half open book structure like this, if it is a half open book structure like this and you have a double bond on this side, so it would be attacked from below the plane only. It would be attacked from below. So if it is attacked from below like this, then both of these methyls and hydrogens, you know, both of these, okay, this is a 6-member ring, so both of these methyls and hydrogen would turn up above the plane. So let me just draw it normally. These hydrogens are below. You have a 5-member ring like this. Both the hydrogen and methyls turn up, and the regio is going to be like this. So what is your answer now? Tell me quickly. Answer is option number C. Okay, we have to be careful once again about the stereochemistry. These two hydrogens cannot be cis. यहाँ पे cis दिया हुआ है, they cannot be cis. One of them is below, the other one is above. So they will be trans as well. So they are trans right over here. They are trans. Here also they are trans. But then looking at the regio, so our answer is option number C. Yes, it was a very good question. You can check out the stereochemistry by yourself once again. Okay, now we are going to move onwards, guys, to another good question. The major product of the following intramolecular cycloaddition reaction is. So, you have an alkene, you have a carbonyl. What do you think, or let's say, the cycloaddition happens first to which bond? Is it a Paterno-Bucchi reaction or a simple 2 plus 2 cycloaddition that you have to say? Oxetane. Sure. Alright. What about everyone? Yes, what does everyone think? Is it going to be a Paterno-Bucchi reaction or a 2 plus 2 cycloaddition? Yes, guys, you have to answer quickly. See, this is not a simple alkene, isn't it? It is the alpha beta unsaturated alkene, which means that it is polarized only. Yes, it is not a simple alkene. So if you say that the carbonyl is going to absorb better, the alkene can also absorb better because it is now a alpha beta unsaturated alkene, and that gives you option number D, isn't it? 2 plus 2 cycloaddition happening first. Not the Paterno-Bucchi reaction, 2 plus 2 cycloaddition. Why? Because also the carbonyl bond is going to be more stable, right, as compared to the alkene bond like this. So hence your answer is option number D. Yes, so 2 plus 2 reaction is going to happen over here. Okay, answer is option number D. So this was a GATE 2018 question, and you have seen the previous question was also a GATE question. So you have seen how the GATE exam is giving you very tricky questions, not as easy as your CSIR exam, or let's say a different level basically. Okay. Now the thing is, we are starting our courses from 1st of December, as I have already told you. A lot of you might have missed it, so I'm repeating. 1st December se we are starting new batch. So we are having the beginners course starting from the 1st of December. The beginners course that is going to be very much in the basic. So we are starting from very basics to your CSIR NET preparation. Alright, so first thing first, since we have extra time, we are starting from December. And another good course, that is the practice booster course for your GATE examination, is again going to start from 1st of December. Okay? Yes, so it is going to be right. So many, there are going to be a lot of courses. You see this course, you see another course on reaction mechanism and reactive intermediates starting from the month of January. So we have planned till December to March. These 4 months you are going to have 5 courses. After March we are going to do revision and practice. So after March we are going to do revision and practice, and this is for your June 2021 preparation. So if you are interested in joining to Unacademy Plus, you can directly use the code JagritiS or JagritiSLive. Alright, and you can join through through this code. Alright, so yes everyone. Okay, so why we are not having Paterno-Bucchi reaction? See, first thing first, it is not a simple alkene that you get. It is not a simple alkene, it is a conjugated alkene like this, isn't it? It is a conjugated alkene, which makes it absorb even quicker, or let's say even faster than a simple alkene, right? Simple alkene won't absorb the light that much. Now you consider 2 plus 2 cycloaddition. There is going to be a bond formation like this, and further the bond is going to open up back to give this kind of a molecule. So ultimately what I want you to understand is that when you have this possibility of alkene having some electron withdrawing group, then it becomes more polarized and breaking the bond becomes easier. Okay, so hence you are having the 2 plus 2 cycloaddition. Along with this, one more thing, that the carbonyl bond is a more stronger bond. So the molecule will want to retain the more stronger bond and react the less stronger bond, isn't it? Yes, so this is our answer. This is how it happens. Alright. Okay everyone, so now I will take a leave and I will see you at 8:30 p.m. today. As I have already discussed in the beginning of the session, I have shown you the schedule of all the last minute practice classes. All the last minute practice sessions that we are doing are very important. So we have the third one today. We have the third practice session today. 8:30 p.m. is the time, and along with that, a 5 p.m. session is going to be our plus class. Alright, so yes, keep that in mind and join up on time. And thank you so much, guys, for joining up. And we are going to, alright, I'm going to see you at 5 p.m. and 8:30 p.m. as well. Have a nice day, all of you. See you very, very soon. Bye.